Okay, if I can invite all speakers to the stage, then we have 10 minutes for questioning. And I suppose there are specifically interrelated questions between the different disciplines. Well, what I would like to know, I think the last three speakers are fighting with each other for orientation. So who is having the last say in this? Who is the most beneficial in talking about orientation? Could you reflect on that?
Actually, if we can build the wider west and east axis buildings for high-rise residences, I guess it's the better because every units can facing a south. So, but because of the earthquake, we usually have the tower for symmetrical things, not to for four-side symmetry, so kind of tower. So we have to have the west side and the east side. But usually the south side is the best, and east side is second best, and west side is not so good. But we have inevitably have the west side of units. So, but south side is one of the best, I guess.
Yeah, but would it also be the optimal situation for photovoltaic cells and for ventilation?
Ventilation. I actually think the hearing the presentation, we always open the door, even if high-rise residences. All the high-rise residences has very big windows, not small windows, from this 2 meter high to 1.20 meter high, because it's our custom, not only for the ventilation, but also the breeze. Breeze is very important for our life, so sometimes we get the wind from outside.
Probably the other thing is, obviously, for us since in Australia, it's actually the opposite aspect. We look at the northern aspect for solar access as opposed to the southern, just obviously because of the location on the Earth. But the main thing we've actually had, and that was one of the job at Chats where we did, they had big issues with solar access. We've got a bit less stringent than you have. You've got 4 hours, ours is between 2 and 3, depends on the location. But probably to be able to have, ideally you're looking at a design that's sort of oriented in that north-south direction. Doesn't matter really where you are in the world, but able to, so that way you get in the east, west and northern aspects, or east, west and southern aspects are getting full amount of sunlight, and you can also just articulate the facade itself as you go along, and you can achieve the ventilation as well. I'm sure that you've had probably jobs as well where you've had to sort of do a marry of those two as well as other aspects as well to be able to blend them all together to create a happy medium. Because essentially that's what it comes down to. It's not just one discipline, it's knowing all the aspects you need to do, putting them all together at an earlier stage, so that the earlier it is, the better the architectural design can be incorporated to marry all of them together.
Thank you. Another aspect of integration was in the foundation. You're right that you consulted the structural engineer many times, but at the same time you're putting the foundation system as a system on its own. Shouldn't be a completely integrated system with the structural engineer modeling.
Yes, of course it is an integrated system, and I've only looked at the geotechnical component, but the thing is that the foundation performance depends on the loads which we provide to the structural engineer, and the loads depend on the foundation performance, so it's an interactive process. So yeah, we're dealing with the system, not isolated components.
I think if I... Do you have additional questions? Okay.
Yeah. I have a question for Mr. Holt. Yes, I heard you mention that the installation of the steel structures is ahead of the reinforced shear wall, core. So how did you take care of the connection from the steel structure to the core? And how do you consider the differentiate settlements of the core and the outer part?
Great question. So the connections I can speak a little bit more to. That was, we had a series of, in order to bring the concrete up behind the steel, we had a series of what ultimately became permanent erection steel pieces that allowed the frame to stay connected to itself, but really was only designed to support the building for a certain number of floors. And then we moved the slip forms up and dropped in the rebar cages and poured the concrete. So we had to keep a very tight spacing from where the concrete was up to where the top of steel was. And at times on Seven World Trade, we actually, the steel was moving too fast and had to wait for the concrete to catch up. So these erection pieces allowed that whole thing to work. There was some complexity to the Perry forming system that we used, but ultimately that was how it worked. In terms of the differential settlements, certainly the structural engineering team, WSP, Cantor Scenic, had factored all of that in relative to the design, as you would in any project. The specifics of that calculation, I'd have to refer you to Ahmad and his team for.
Thank you.
Okay, if there are any final remarks to be made, you think you missed? In that case, we made our rescheduled scheme thanks to cooperation of all the speakers, and I would like to thank them again for their contributions.